Welcome to Study Loop.
So here in this question, let's imagine this situation first. So let's assume that this is a hill and car B is towing car A at constant speed of 10 meter per second. So let's assume that this is car B and this is car A. Sorry, we have to make tires too. Now they are tied with a rope, let's say, and car B is towing car A at constant speed of 10 meter per second. So this is a speed of 10 meter per second on uphill grade when the brakes of car A are fully applied, causing all four wheels to skid. Now, weight of both of the cars is 1400 kg and 1200 kg, and the coefficient of friction or kinetic friction is, which is represented by mu k, and that is 0.8. And we don't have any air resistance. So in the first part of this question, to determine the distance traveled by the cars before they come to a stop, we can use the equation V or S is equals to ut plus half a t square, where u is the initial velocity and we do not have any initial velocity over here, so we can use d is equals to half a t square. And here d is the distance traveled, is the acceleration, and t is the time. The acceleration of the car is given by a, and that is equals to the frictional force upon mass, that is m1 plus m2, where m1 is the mass of the first car and m2 is the mass of the second car. The frictional force is given by the coefficient of kinetic friction into m1 plus m2 into g, where g is acceleration due to gravity. So substituting the known values into the equation above, the acceleration a is equals to 0.08 into the mass of the first car, which is 1400 kg, plus 1200 kg into acceleration due to gravity, that is 9.8 meter per second square, upon the total mass of both the cars, which is 2600 kg, and that comes out to be 8.56 meter per second square. The time it takes for the cars to come stop is given by t, and that is equals to the velocity upon the acceleration, where v is the initial velocity of the cars, and initial velocity of the cars is 10 meter per second, and therefore the time it takes, t, is equals to 10 meter per second upon the acceleration, that is 8.56 meter per second square, and this comes out to be 1.17 seconds. Substituting the known values into the equation of distance traveled d is equals to half into a, that is 8.56 meter per second square, into t square, that is 1.17 seconds whole square, and this comes out to be 5.46 meters. And in second part of this question, the tension in the cable T, here it will be experiencing a tension in the cable, which is represented by T, and the tension in the cable is equal to the force exerted by the car B on car A. This force is equal to the mass of the car A times the acceleration of the car. So tension T is equals to the mass of the car A, or we can say 1 into the acceleration. So tension T is equals to 1400 kg into acceleration, that is 8.56 meter per second square, and this comes out to be 12,000 Newton. So I hope this answered your question. Thank you.